Good morning, students. Today we are going to learn how to name the coordination compound, that is the nomenclature of coordination compounds. Iupac nomenclature. What are the rules given to name the coordination compound will be explained in this video. In the earlier days, the compounds were named after the name of the discoverer. So here an example is scissor salt, that is KPtCl3C2H4. PtCl3C2H4, this is scissor salt which is named by the discoverer. Likewise, there is Magnus green salt, that is PtNH34PtCl4, and this was also named by the Magnus green, the discoverer name. So but later part there are so many compounds were synthesized and prepared in the laboratory, so there was a lot of confusion. So to avoid that, there is IUPAC nomenclature, that is International Union of Pure and Applied Chemistry, are given some rules to be followed, and this is the rules here given. That is the revised rule at the year of 2005, how to name coordination compounds. So let's see what are the rules to name the coordination compound. First point, the cation is named first, followed by the anion, regardless whether the ion is simple or complex. Now I have taken one example, K4FeCN6, to ionize, right? So the element which is present outside at the left hand side, the first one is cation and the complex is called to be the anion. So whenever you name the complex, the cation is named first, then next will be the anion, and you should not worry about whether it's a complex ion or a simple ion. So whatever may be, the thing which come first has to be named first. Another example, CONH36Cl3. Look at this complex where the first thing is complex. So this complex carry positive charge and the Cl is the counter ion. So Cl is carrying the negative charge. So in this case, first we will start naming the complex. The another example, PtNH34PtCl4. Look at that. This first complex carry positive charge and the second complex carry the negative charge. So the complex cation is PtNH342+ is named first, and then PtCl4 2- because this is a cation. So always the cation will be named first, then the anion. You can look at here. This is a neutral complex, so there is no charge at all. So automatically we'll nothing at the left hand side as well as the right hand side. So you will name it. But look at this. In this case, the complex carry the positive charge. So first we will name the complex. See that pentamine cobalt, pentamine. But here the answer is wrong. Pentamine chlorido cobalt. Okay, so they did not mention chlorido. So first we are naming the complex. The next here, first we are naming potassium. This is the cation. So potassium, the next complex. Here to the first cation is potassium. So potassium hexacyano. This compound will be named. Second point is the simple ions are named as in other ionic compounds. So other ionic compounds means you can take NaCl. So NaCl sodium, Na plus. NaCl ionized to give you Na plus and Cl minus. So if there is simple ion, that sense the counter ions. A complex compounds have counter ion as well as the complex entity. If the counter ions can be either present at the left hand side of the complex or else the right hand side of the complex. So the counter ions are either this Na plus, K plus, etc. Anions will be SO4 2-. So these counter ions will be named as normal name, like sodium Na plus, chloride Cl minus, potassium K plus, nitrate, that is NO3 minus will be nitrate. copper Cu2 plus sulfate. No change in the name. When we name the counter ion, there will not be any change in its name. Okay, as it is, we will write the name. Third point or third rule, to name a complex ion, the first the ligand are named first, the next the central metal atom or ion. When a complex ion contains more than one kind of ligand, they are named in an alphabetical order. So here you can see that there are how many ligands? Two ligands, NH3 and Cl2. So NH3 name is amine, A-M-M-I-N-E. Cl, its name is chlorido. So the first letter of amine is A, first letter of chlorido is C. So in alphabetical order, the first we will write the amine. That's what here, diamine. Why it is diamine? Because there are two amine. So diamine, dichloro. This was before 2005 it was called to be chloro, but now this is named to be chlorido. Okay, chlorido. Next is the metal atom. That's what, while naming the complex, the ligands are named first, followed by the central metal atom. But the complex ion contains more than one kind of ligand, we will be arranging that in an alphabetical order. So this also we have two ligand, one is amine, another one chlorido. So the first we will be naming the amine, next only we will move to chlorido. Next to naming of ligands, how to name ligands. Ligands can be anionic ligands, cationic ligands and neutral ligands. So let's see how to name these ligands. If it is an anionic ligand, the name of that ligand will end with O. For example, we can take anionic ligand of cyanide, Cn minus, Cl minus, chloride, fluoride, sulfate, nitrate, nitrite. Okay, these are called to be the anionic ligands. So normal case, when you name it, you will name it as cyanide, chloride, etc. But when you name this as a ligand, and you will write it as cyanido, it end with O, and chlorido, fluorido, sulfato, nitrito, etc. So anionic ligand end with O, but the cationic ligand end with IUM. So you can see cationic ligand NO plus, NH2 single bond, NH3 plus. This is nitronium, IUM. This is called to be hydrocenium. So both are having IUM. There is third ligand, neutral ligand. Neutral ligands with this its own name. Like this is one neutral ligand, does not have any charge. It is pyridine. So nitrogen will have a lone pair of electron that will be donated to the metal atom and form a bond. The name is pyridine. So in the naming of coordination complex also we just write it as a pyridine. But there are some few exceptions, namely water, it's a neutral ligand, no charge, but oxygen will have a lone pair of electron. So the water, while we name it as aqua. Then CO, that is carbon monoxide, that is named to be carbonyl. NH3, it's a neutral ligand, named to be normally ammonia we used to say, but here we will say this is amine, A-M-M-I-N-E, amine. And NO, called to be nitrogen monoxide, it's called to be nitrosyl in this case. So this is naming of ligands. Here a term K is used to denote an ambidentate ligand. So ambidentate ligand is nothing but one coordinate in more than one way. That is like you can take this nitro group NO2, where N is the atom which donate the pair of electron to the central metal. So in nitro group, either through N it can make a coordinate bond, or else through oxygen it can make a coordinate bond. So if it make it through nitrogen, we will represent, after writing the word nitrito, we will be writing Kn. If it is coordinating through O, then we will be writing Ko. That's the only difference. Likewise, there is a particular example given. One ligand, that is thiocyanate. This thiocyanate can capable of coordinating in two different way. That is through sulfur it can coordinate to the metal atom, or else through nitrogen it can coordinate. This is thiocyanate, where it can either coordinate through nitrogen atom or else through sulfur atom. If it coordinate through nitrogen atom, the name will be the same name, thiocyanato Ks. It is coordinating through sulfur. Thiocyanato Kn, it denotes it's coordinating through nitrogen atom. Next is, if the complex have more than one ligand of a particular type, like take an example of this, K3AuCN4, one ligand, same kind of ligand, but there are how many ligands are there? 4 ligands. So if it is more than one ligand, same kind of more than one ligand, then we have to use the word called to be, if it is 2 ligand, we will be naming it as di. If it is 3, tri. If it is 4, tetra. Now there are 4 ligands, so we just have written tetra, tetracyanato. This is tetra. Now, if the name of the ligand itself containing Greek prefix like En, ethylene diamine, it has a prefix already in the name, di is there. So once the name Greek prefixes come, therefore we will be using another one word called to be, instead of di we will 2. Instead of 2, normally we are writing it as a di, but here if there is a En, already we are getting the word di, hence we will be using the word bis. If it is 3, we will be using the word tris. If it is 4, we should be use the word tetrakis. Okay, that's about the naming in one part. Already I said there are positive ligand, negative ligand and neutral ligand. Here there are some examples of ligands. Then how to name these ligands? Let's see that. Bromide can be named to be bromido. These are negative ligand. Even in the yesterday's video we have seen this, and I told you all to learn this. So bromido, chlorido, fluorido, cyanido, hydroxido, carbonato, nitrato. Then this nitrito is a ambidentate ligand capable of coordinating more than one way, either through nitrogen or through oxygen. Hence we will be using the word Kn, Ko. Then sulfato, sulfido, oxalato, ethane 1,2 diamine. That is nothing but this ethylene diamine is ethane. When you write the ligand name, the name should be ethane 1,2 diamine. Already we are getting the Greek word, that is di. Hence when this compound comes, if it is twice we will write bis, if it is thrice we will be write tris, etc. Another one is this EDTA, ethylene type. This is a common name, ethylene diamine tetraacetate. But here it's negative charge, so it will be end with O. So that is tetraacetato. Then triphenyl phosphane, it's a neutral ligand. Another one is pyridine. So these are some of the ligands, and how to name those ligands in coordination complex is given. Next, how to name the central metal atom or ion. So in a cationic or a neutral complex, the element name is used as such. That is, the central metal atom name should be named to be as such. So let's take an example of few. Look at this is a cationic complex, and these two, not the last one, is a neutral complex. So in a cationic complex as well as in a neutral complex, and this can also be a cationic, and this is cationic complex, and this is a neutral complex. So there are two anionic complex. So in cationic as well as neutral complex, the element name is used as such. The element means the central metal atom name is used as such. So this is a cationic complex. So CO is cobalt. Its name will be pronounced as cobalt, and you will not change its name. But in the case of anionic complex, the central metal atom name will end with the word ate. So this is ferrous, as it carry minus charge in the complex, so it's an anionic complex. So the name of the metal atom will end with ferrate. And this is a cationic complex, the name is citrus, that is cobalt. This is also cationic complex, so the name will end with iron. No need to mention it as ferrous or ferric like, just you can write as commonly iron. Come to this neutral ion, so it's chromium. No change in that name. But this is K plus plus VCO, this minus. So this vanadium will be called to be vanadate, AT, negative complex. But this is neutral, so manganese, it's named to be manganese itself. Next, the oxidation state is written immediately after the metal atom. So this is the metal atom name, that is like ferrate. Immediately after that, you will write its oxidation number in a Roman numerals as well as in parenthesis. Then this two, iron, Roman letter 2, chromium 0, and vanadate, its oxidation number is K plus plus V. Carbonyl is neutral ligand, so this is minus. So minus 1, its oxidation status minus 1. So we are, as its charge varies, so we are writing minus Roman letter 1. And here manganese again, it's minus 3. So you'll be writing minus 3. This is the oxidation number. As I told in the previous slide that normally these elements are when it is in the cationic complex as well as the neutral complex, it will be named as it is: chromium, zinc, aluminium, iron, etc. But when it is when these metals are present in the anionic complex, the name will end with ATE: chromate, zincate, aluminate, ferrate, cuprate, cobaltate, plumbate, argentate, stannate, aurate, platinate. So you have to learn these names, okay? Thank you, students.